Greetings, everybody, wherever you may be. Welcome again to Kourou, the home of Ariane, for today's live and daytime broadcast of Arianespace flight number 165. We're coming to you, as always, live from Europe's spaceport in French Guiana. Stay with us. The last Ariane launch of the year coming up.
French commentary today by Pierre Junière and Muriel Bailly. In English, you will hear Joshua Jean-Paul and me, Jean-François Lemonnier. Spanish is by Matias Valbuena. You will follow us on internet at www.arianespace.com. Ladies and gentlemen, on behalf of the Defense Minister, Madame Michèle Alliot-Marie, I am happy to welcome you to this live broadcast of the launch of HELIOS 2A. The Defense Minister and all the partners in the HELIOS 2 program know the importance of this event for our armed forces and for the development of a European cooperation in space. I would like to welcome everyone watching today at the École Militaire in Paris, to our viewers in Kourou, and to all those following events from different sites. You all know the important role our ministry believes the space sector plays. A few days ago in the French Senate, we heard that space is the turning point of the 21st century. I would like now to turn this broadcast over to Arianespace at the CSG for more information on the launch preparation. Thank you and enjoy the afternoon.
Et vous souhaite à nouveau un très bon moment.
Jean-François Bureau of the French Defense Ministry, welcoming everybody. I'd like to welcome another Jean-François up here in the booth with me, Jean-François Lemonnier. Hello to you.
Yes, Joss, hello. Hello, everybody. Good afternoon in Evry, in the French Ministry of Defense in École Militaire in Paris. And hello to our internet audience.
As the camera zooms in on the ELA-3 launch pad, you can see the Ariane 5 waiting on the pad. You see what the weather's like. Sunny, hot, little bit more clouds today than yesterday and the rest of the week, but no weather problems at all, huh? As we look into the Arianespace Flight Directorate with Jean-Yves Le Gall, the Chief Executive, you'll be hearing from him in just about a minute. You'll be hearing from him 2 or 3 times during the evening, as a matter of fact. A big launch tonight for the French Defense Ministry and for the microsat community. And we'll be back with that in just a moment. But for now, we're going to look at the Arianespace CSG tandem, the mission director and the DDO.
Yes, Dan Murray is mission director today. He's interface between customers and launcher during the chronology. He's with Jean-Marc Durand, his deputy. Thierry Vallée is range operation manager for this mission. His role is to make a complete synthesis of all information coming to Nerve Center Jupiter for the go-to launch.
Dan Murray's 9th launch, 9th mission as mission director, Thierry Vallée his 3rd as the DDO. The two of them work together, one Arianespace, one CNES CSG, orchestrating the Ariane launch, overseeing general coordination, the DDO mainly base operations, and you'll be hearing his voice as he calls out the milestones in the mission tonight. The CM handling customer support, much like you do in your job.
Yes, Caroline Arnoux and her deputy Christophe Bardou are payload directors tonight. They are the program directors in charge of our customers for this mission.
The mission, which is an interesting one tonight, as we mentioned, for the Defense Ministry, HELIOS, and 6, count them, 6 microsats. Christophe Bardou, who is your colleague. 164th Ariane launch of Ariane's career, the career of the family, I should say. The 17th commercial launch of the Ariane 5, the 20th Ariane 5 in all, and the 3rd and last launch of this year. We're going to go now to the first of a couple of recorded interviews with Jean-Yves Le Gall, whom we shot 2 days ago, and he'll be giving you a look at the mission.
We are 2 days from the launch of Flight 165, here in the final assembly building where the launcher has been prepared. Behind me, inside the fairing, are the satellite HELIOS 2A and the microsats ESSAIM, PARASOL and NANOSAT. 2 days' work will be dedicated to the final checks. Then the platforms, like this one, will be removed. Tomorrow, this large door here will be opened and the launcher will be hauled on its launch table to launch down about 2.5 kilometers away. The day after tomorrow is launch day. Flight 165 is special for two reasons. First, we don't have, as usual, a launch window. We have instead a launch at the second. This means we must lift off at the precise moment indicated, 13 hours, 26 minutes, 12 seconds local time. Then, following the propulsion phase, during which the different stages of Ariane will push the vehicle, we will enter into a ballistic phase. On launch day, we will lift off, the boosters will ignite, the EPC core stage will power Ariane 5 into space, and after 27 minutes, the EPS upper stage will complete its mission. We will then be over northern Canada. At this moment, the EPS and the satellites will continue in the ballistic phase for 33 minutes. At the end of this time, we'll be flying over the Indian Ocean and Western Australia. This is when we will begin the separation sequence, which will last for 8 minutes. After this, HELIOS 2A and the ESSAIM satellites, PARASOL and NANOSAT, will be put in their final position on orbit.
So all that is ahead for you. We hope you'll stay with us, with Jean-Francois and me, as we live together through these final moments of the final countdown. The green status panels popping up now. These are the go, no-go summaries of all the mission support services.
Yes, on the status panel is displayed the status of all means necessary for the chronology. When status is green, they are ready and available. They are grouped in 4 categories: the technical means, like telemetry; synthesis, like launch authorization, range data; decision heads, like weather and safety; and sure, launcher and satellites.
A lot of activity here in the very big space base with all these support services and their information coming in here. Over to Dan Murray now for a description of today's mission.
Flight 165 today will launch 1 main passenger and 6 auxiliary passengers on Ariane G5. The main passenger is HELIOS 2A, part of a CNES project for the French government and the French armed services. The auxiliary passengers include 4 ESSAIM satellites built by EADS Astrium, also for the French armed forces. These are small demonstrators or mini-sats, which will work in the electromagnetic environment. The 5th auxiliary passenger is also a microsat called PARASOL. This scientific satellite will study the microphysics of clouds for CNES and LaTeX. When in orbit, it will be part of a cooperative project called Aquatrain. The last auxiliary passenger is NANOSAT, a small satellite weighing about 20 kilograms. Developed and built by INTA in Madrid, NANOSAT is a scientific and technological demonstrator. The value added that Arianespace, as a launch services provider, can offer is a global service which we make available to customers. Right from the start of mission preparation, we provide everything you need for its coordination, up to the contractual commitment, placing all our passengers in orbit. Today's mission is a launch on a polar trajectory. It's an SSO mission, which means sun-synchronous. As a consequence, HELIOS must be delivered on a precise position on the orbit. The liftoff must be within the second.
Rendez-vous justement, eh bien, nous n'avons pas de fenêtre de lancement, c'est un lancement à la seconde.
Arianespace waiting on the pad, along with all of us. We're here in the Jupiter Mission Control Room. Again, looking down into the fishbowl where the technicians are at their screens. Behind them, the invited guests and the VIPs.
We can see Bernard Lamaison, who is the Satellite Mission Director for HELIOS 2. He's from CNES. And his deputy is Jean-François Gory from CNES also. Eric Beaufumet is DMS for the 4 ESSAIM minisats. He's from EADS Astrium. And Vincent Dubourg is DMS for PARASOL. He's from CNES.
These gentlemen are the customer program managers. I guess that's the title. There's one more coming up.
One more coming is Manuel Angulo. He's a DMS and CPS for NANOSAT. He's from INTA in Madrid.
And we'll be hearing from...
À 12 de DDO, attention pour le H0 7 minutes.
DDO is going to call out the 7-minute mark.
Top H0 7 minutes.
We'll be hearing from the gentleman that we just saw a little later on in the broadcast describing their satellites. The DDO has called out the 7-minute mark, which is one of the last milestones in the final moments of this final countdown called the synchronized sequence or the automatic sequence.
Yes, the synchronized sequence is a period of 7 minutes during which two computers, one dedicated to fluids and one dedicated to electrical functions, will run a series of operations on the launcher and the ground systems. Its main role is to start and check the last operations for the launcher to be in flight configuration.
There are 1,001 last operations to be checked out in a complicated launch vehicle like the Ariane 5, as you can imagine. So we need computers to do it. And these two computers are located in the CDL, which is the Launch Management Center. We'll be up there shortly. But for now, take a look at the latest news from Arianespace. At the last International Astronautical Conference in Vancouver, Arianespace, Russia's space agency in space industries, the International Astronautical Federation, and the World Space Agencies decided to commemorate the launch of the very first satellite in 1957. This will be carried out by placing in orbit 50 nanosatellites, each representing a different country. The nanosats will weigh 1 kilo each and be dedicated to a single scientific experiment. Each will have a 2-year lifespan and be managed by academics and researchers. They all will be launched in 2007 by Arianespace.
At the 6th International Space Transportation Summit in Paris, Arianespace confirmed its #1 spot on the market before the world's satellite operators. One of the company's advantages is being able to offer the services of two other top vehicles through the Launch Services Alliance, with BLS and MHI. This ensures customers reaching orbit on time.
United States satellite operator DirecTV has chosen Arianespace to launch its two next telecommunication satellites. The first of these, Spaceway 2, weighs 6.1 tons. Both satellites will expand the offer of direct television service delivered by satellite. For the first time, at the signature of a double contract, Arianespace offered a completely new approach, which lets the customer first choose an overall mass for both birds and later decide the final mass of each.
America's #1 satellite operator, PANAMSAT, has chosen Arianespace to launch Galaxy 17, its newest bird. Galaxy 17 will be launched aboard an Ariane 5 from Europe's spaceport by the end of 2006. It will be the 21st launch for PANAMSAT. Arianespace launched its first on the inaugural flight of the Ariane 4 in 1988.
Shot of the fairing, the 7. Count them. 7 satellites are inside there as we pull away. The boosters stand about 31 meters tall. It's to give you an idea of the overall height of Ariane. That radio tower figure in the background is not a radio tower, actually. It's a lightning rod, isn't it? And there are 4 of them. The greens again, all green and all is go. We're on time and we're on target. We're still in the synchronized sequence. We will be down to liftoff time. Computers are taking over. It's a rather crowded schedule, 7 minutes, but it does leave us a margin.
Yes, in fact, there is time for all the operations in this automatic sequence.
And as we mentioned, there's so many of them. If we take too long, we stop the countdown and we have to start over. Camera moves up now to the CDL. This man is the COL, or called the Launch Site Operations Manager. We'll be hearing from him in a moment. And his team are checking out the final launch operations.
Yes, André Sicard is the COL today for this HELIOS mission. We see the CPAP, Mr. Chomlou.
The computers that are checking out these fluids and electrical systems during automatic sequence that you talked about, Jean-François, are located up here at the CDL, about 13 kilometers to the northwest of where we are here in Jupiter.
Yes, the two computers are located in the basement of CDL3.
Power passing now from the ground computers to the onboard computers on the Ariane 5 as she becomes more and more autonomous, ready to begin her mission. These shots taken about 12 hours ago. Ariane 5 coming out of the final assembly building. You can see the big door rolling open. Flight 165. She was moving out toward the launch pad on a rail track.
Yes, on the track we have a big table, which is about 1,500 tons, plus the vehicle, which is 750 tons. So it's a big payload, and this is pulled by a truck up to the launch pad, which is about 2.5 kilometers from the final assembly building.
Rolling at about 2 kilometers an hour. The whole thing doesn't take too long to get out there, but they have to hook up all the wires and the cables and everything once they are out there.
And we could see the train following the convoy, in fact, to supply energy to the payload during the transfer.
Energy and ventilation
and
systems.
Air conditioning and telecommunications.
À tous de DDO, attention pour H0, moins 1 minute.
The DDO, Thierry Vallet, will call out the 1 minute mark coming up, and we will be into the final 60 seconds of Flight 165, followed on the internet, Arianespace.com.
Top H0, moins 1 minute.
All right, we're going to go down to 60 seconds, and we want to give you just a look at the final ignition sequence, what you're going to see when the engines light up. Tell us about that.
Yes.
At H0, you have the hydrogen valve that is going to open. That's on the big Vulcan engine.
Yes, at 6.8 seconds in the synchronized sequence is the last check. At this moment, the two ground computers will send the order for Vulcan engine cool down and will ignite some pyros to burn the hydrogen used for the cooling. When the Vulcan chamber will reach the right pressure, the solid rocket booster will be ignited and liftoff will happen about H0 plus 7
À tous
seconds.
de DDO, attention pour le décompte final.
The DDO with the final 10 seconds. We'll see you after liftoff. Enjoy it, everybody.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage AP et décollage. Les paramètres bord sont normaux.
Lovely sight, a lot of light and a lot of noise. The DDO says that all is on board, normal. On the screen, Toucan, that's the camera, that's the cine camera from the islands across the bay, across the ocean. You see Ariane rising, tilting over now towards the north.
Yes, at an altitude about 300 meters over the pad, the launcher is taking its trajectory to go to north.
The core cryogenic stage and the two boosters burning now. The boosters, which will burn for about 2 minutes, each with roughly 240 tons of solid fuel.
Les paramètres bord sont normaux.
Yes,
All on board is normal, says the DDO.
yes, the performance of the boosters, in fact, are far sufficient to extract the launcher for Earth's gravity, and this will be continued by EPC. It's the main work of these solid 2 boosters. And after that, after their separation, we'll only weigh 150 tons compared to the 750 we had at liftoff.
At liftoff. So we lose a lot of weight quickly. You can see the people streaming back in to their seats, the VIPs in the background of your screen there. They were out on the 2 balconies on either side of the Jupiter building here watching the launch. It's a magnificent daytime launch, which we haven't seen here in quite a while. On the left of your screen, on the upper half, you see the cursor climbing up. We have 2 superimposed trajectories. One is the optimum and the other is the real-time trajectory. As long as they are one and the same, we're doing fine. On the bottom left-hand of your screen, you have numbers.
The indication of the altitude in kilometers. We are now close to 80 kilometers. And the speed in kilometers per second. We are just over 2.
That looks like the booster separation there that we just saw with the naked eye. The sky is so clear. This is roughly what it looked like. You just got a glimpse of that, the two boosters firing away to either side after doing their job, burning for a minute and a half. The EPC, the core cryogenic stage now, burning alone. What happens to the boosters? They drop in the drink, right?
So the booster will fall in the Atlantic Ocean.
And they're not reused, they're not
they are not
analyzed
reused or recovered.
As Jean-Francois mentioned, we're on the lower left-hand side of your screen, 111, 112 kilometers. You see how fast we're climbing in altitude. The A and the V at the bottom, velocity, 2.2 kilometers per second. Climbing up, the cursor's climbing up to SEPQUAF. I don't know if you can read that. That's separation of the fairing. You hear the DDO call that out. There he just said separation of the fairing, so we are right on time and on target. The fairing, you can see the two halves blown apart by pyrotechnic cords.
In fact, the fairing ensures the protection of the payload during the atmospheric flight. It's separated after 3.5 minutes at about 130 kilometers when it's not needed anymore. It's made of two halves, which are separated by a pyrotechnic system, one horizontal and one vertical system.
Roughly the same sort of separation system for each stage? Roughly?
Roughly for the horizontal, but the vertical is a bit different. In fact, it will also push the two halves to give impulse to avoidance of payload.
The speed, V, velocity, vitesse in French on the bottom left, 2.5 kilometers. What's the speed we need for injection of the satellites?
We should raise up to 7.6 kilometers per second.
So a while to go. Coming up on 4.5 minutes into flight number 165, HELIOS for the MOD, the French MOD, and half a dozen microsats. The fairing, as Jean-Francois mentioned, jettisoned when it's no longer needed. André Sicard, the COEL, on the launcher and the satellite campaign now.
The 165 launch campaign started at the end of October with integration of the main cryogenic stage and the two solid rocket boosters. Following these activities, all electrical and fluids checks were nominally performed. During this final phase, Ariane 5 ECA launcher activities were conducted in parallel. Then the launcher was transferred to the final assembly building. This campaign is special in that combined operations with the payload were conducted in two parts. First, the 6 microsatellites were integrated on the ASAP adapter, which had been previously mated on the launcher. Then, the combined operations plan was similar to a single launch version for the integration of HELIOS 2A. After that, the fairing was installed to encapsulate the entire payload. As usual, we then filled the launcher's upper stage with storable propellants. The final operation was the transfer of Ariane 5 to the pad, where we are ready today to proceed with the launch.
You can see it back into Jupiter now, 214 kilometers up and 3.5 kilometers per second is our speed. The EPC, the cryogenic stage, is the only propulsion now. We're about with 6 minutes left in that EPC burn. This stage is actually filled about 5 hours before liftoff. Now, why that?
Why is that? Because we need to chill down all the lines to feed the tanks and the tanks themselves. Remember, the cryotechnic fluids we use are for one at minus 250 degrees.
Oh, so that's cold. So if they're already cold,
very cold.
What do you have to chill them down for?
Because otherwise, running in the lines and the tanks first, they will boil completely and they evaporate. So we need to cool down all these structures and tubes.
It takes a long time.
Yeah, and we have to feed about 26 tons of liquid hydrogen and 131 tons of liquid oxygen.
That's the mix.
That's the mix. And the engine will function during about 10 minutes.
We're going to look at a film by the French Space Agency now, all about how satellites are put on orbit.
Symphony, the French-German telecommunications satellite launched in 1975, was the first to be positioned by the CNES Space Center in Toulouse. The Space Center has since forged itself a worldwide reputation as an expert in satellite positioning. Its operating teams have accompanied tens of satellites into orbit. For Ariane 5 Flight 165, CNES will be positioning 6 satellites at a time, another first. This critical phase calls for close coordination between operations specialists, satellite experts, and control centers. 17 stations around the globe, coordinated from Toulouse, send telecommands to the satellites and receive data. The Operational Orbit Determination Center receives the positioning measurements needed to calculate the orbits of the 6 satellites for tracking purposes. Using this information, the control centers send a series of commands to each satellite to maintain their mission orbit and allow them to fulfill their mission in optimum conditions. At the end of the day, over 150 engineers and technicians in Toulouse will be working to ensure the 6 satellites reach their intended orbits.
And they will be reaching their intended orbit shortly. Less than a minute to go on the EPC burn. During the clip you saw in the upper right-hand corner where the clock is ticking there, the altitude, A, and the velocity, speed, the figures up there. Keep your eyes up there because we'll have the latest figures, latest telemetry data while we're watching any films. Coming up on the first half of the mission's completion. As we mentioned, Ariane 5 is in 2 parts, a lower and the upper composite. The EPC is the first half. And
yes.
What happens when we're going to be burnt out of our EPC stage?
So after its separation, the main cryogenic tank stage will fall naturally after its separation, close to the North Pole. In fact, we will depressurize the tanks by means of lateral nozzle. This will make it spin and will stabilize it until it reaches the atmospheric sphere and will re-enter just over the North Pole, but probably destroy at that moment.
So the DDO has called out separation of the EPC, the big core stage you see falling away. 6 seconds later, the onboard computer gives the order to light the Estes engine, that's the sole engine on the EPC, the upper stage. So we're rolling now on 1 engine. The upper stage, storable propellant engine, it's called the EPS, the upper stage, 10 tons of storable fuel.
Yes, the upper stage, or EPS, has to provide the energy now necessary for satellization of the payload. It will also ensure the orientation of the vehicle and for each satellite and the separation at the right moment. Its 4 tanks carry some storable propellant, MMH and N2O4, a bit like satellites.
Same system as satellites, but different system than the core stage, which was the cryogenic fuel, the very cold fuel. This is the older technology, the storable propellant. Yeah.
It's still used on some vehicles and satellites.
Not as good performance, not as efficient as cryogenic stage. Coming up on 500 kilometers up and coming up on 7 kilometers per second on flight number 165, the last of the year. 11 minutes into the mission, the DDO keeps calling out that all is nominal and normal on board. So the role of the EPS, you were saying, is to adjust the satellization of the payload so they can more or less reach their target orbits. And the right orientation for separation. It also delivers the final velocity. It's a question of speed because you have the solid boosters getting the speed to break out of the Earth's gravity. Then you have the core cryogenic stage continuing that work, and now
it's the EPS.
So it's like the gears on a car: first gear, second gear, third gear.
Yeah, a bit like that. I think we should approach the time of leaving visibility to Kourou, probably, or acquiring
You're right on
Canada.
target. We've just been picked up by our first downrange tracking station over the Great Lakes, near the Great Lakes in Canada. It's a Canadian Space Agency station in Quebec called Saint-Hubert.
Saint-Hubert was used previously by Ariane.
Going to the first of the Defense Ministry films now. We'll be back. Yes, this is the Ministry of Defense night here. France playing a big role in European defense, of course. Before we move on with them, however, we do want to say just another word about Saint-Hubert. Not the first time the Canadian station has been used for the Ariane program. It was used in 2002 twice to track Spot 5 in May of that year and to track the NANOSAT, the big 8-ton
Mr. Marc Bizan is the responsible system for HELIOS 2A.
The DGA, 10 minutes left in the upper stage burn, the DDO saying. The DGA is the French Defense Procurement Agency, part of the MOD, in charge of the entire HELIOS program. CNES, of course, the French Space Agency, being assigned the space segment. Alcatel building the high-resolution imaging instruments on board, and, of course, Arianespace launching it. We're moving into the second half of the mission with the upper stage, so we can focus on the satellites a bit now. So how about some news on HELIOS?
Yes, HELIOS 2 program is destined to ensure continuity and improvement of governmental service for Earth observation. It's operational since the launch of HELIOS 1A in July 1995 and HELIOS 1B in December 1999. Program regroups today France, 95%, Belgium and Spain for 2.5% each.
So it's mainly a French-led project.
But HELIOS 2 system is an open system. It will allow for integration of new partners in Europe.
Represents about 12 years' work between CNES and the Army and Ariane and everyone. HELIOS 1A, as Jean-François mentioned, going up in 1995. We'll be back with more, but for now, an interview with General Henri Benezat.
The launch of HELIOS 2A is very important for the armed forces because it will provide us with new capabilities. These capabilities, in particular, concern everything dealing with the volume of transmitted images, with the speed of transmission of these images, and with the ability to record them at night and in high resolution. The precision of these images will be significantly improved over those transmitted by HELIOS 1. These new capabilities are crucial for the armed forces in two ways. For management of crises, which we call strategic survey, and for conducting our operations. As for the strategic survey, it gives us the possibility to obtain permanent information files on these crisis zones and to verify that there are no transgressions of the rules in force preventing weapons proliferation. As for the operations themselves, on one hand, we're going to increase our strategic independence. We'll be able to benefit from these files transmitted in real time, coming from a crisis area independent of any surveillance carried out by our allies. On the other hand, we'll have the possibility to vastly improve the preparation of our missions and the return of these missions. In other words, we'll know precisely what happened and what the results have been of those missions we've carried out. HELIOS 2 will also let us carry out the digitalization of battlefields much more easily. This means through a more elaborate mapping system, we can correctly and more easily program our ballistic cruise missiles. Finally, HELIOS 2 represents a major progress for European defense, since this program, developed with Belgium and Spain, will be open to Germany and Italy, but will also offer to the European Union, Greece, and others. In all, European defense will benefit.
HELIOS 1A, we started to say, went up in July of 1995, Flight 75 for Ariane. Along with that went an Alcatel-built microsatellite called Cerise, Cherry in English, weighing 46 kilos. HELIOS 1B went up exactly 5 years ago in December of 1999, Flight 124, along with another 46-kilo Alcatel-built micro called Clementine, or Tangerine. And they're saying that the ESSAIM project, which is one of the micros flying tonight, is a successor of Clementine. We'll be working in electromagnetic waves.
Exactly. We'll listen to electromagnetic waves and radio waves.
Again, part of the defense for Europe.
If I speak a bit more about HELIOS system, in fact, the orbital characteristics of HELIOS are based on low orbit to improve the quality of high-resolution images. It's also synchronous to allow for regular lighting of covered regions. The infrared capacity of the high-resolution instrument allows for indication of activities night and day, and so to have 2 access per day at the same region.
2 access because on the sun-synchronous orbit, the satellite will make 2 passes over the same area every 24 hours.
Yes, exactly. The satellite mission consists of a wide field of view instrument similar to that carried on Spot 5, which also covers the visible and the near-infrared ranges. A dedicated high-resolution and very high-resolution instrument operating in the visible and infrared ranges. And the payload bay contains all the mass storage and memory necessary to record the images. HELIOS 2 incorporates major technological advances in agility, reactivity, storage capacity, and significantly improved resolutions, which means that France and her partners now have greater capacity for autonomous appraisal of high-quality data.
The autonomy question, of course, very big for Europe and space, which was behind the entire Ariane program in the beginning. François Leroux, the head of the DGA. coming up.
HELIOS, quel joli nom, c'est d'abord...
HELIOS is, first of all, a superb technological development to serve the armed forces and our political leaders in France and in Europe. It's not merely a technological object, but it's also a very large and complex project, which is my responsibility to bring to life as head of the DGA. This project not only includes the satellite, but also the ground segments, with all the information and data handling systems necessary. It's also a European program, and I believe it's essential today to have a European program in which several countries participate, one which is also a way to exchange information among European nations so that together our decision makers have at their disposal the best information in order to make the best decisions in real time. If we look a bit farther ahead, I think that with HELIOS and in space, we have the tools of European strategic autonomy. We must continue our efforts in this area. We need a shared program based on existing technologies in Europe, in which we'll continue to develop the capacities our Europe will need starting in 2010. HELIOS prefigures the spatial capabilities Europe will need to maintain its independence, and I think HELIOS shows that Europe can be perfectly autonomous in space.
Again, the independence question for Europe, which is so very, very important. We mentioned that this is our first day launch in how long? 5 years. So we want you all to consider how lucky you are to have seen all the people on the beaches and filling their video cameras full of those fine shots we saw. The last day launch we had, there were two of them back-to-back actually, in 1999, exactly 5 years ago. There was one on the 3rd of December, 1999, Flight 124, and that was, of course, Helios 2B with Clementine. And 7 days later was Flight 119, an Ariane 5, the XMM, that's the European Space Agency X-ray probe. Back-to-back day launches, and before that, we have to go back to 1995, Flight 75, for the first Helios 1A. So it's not something we do every day. Picked up now by, as you can see, another tracking station. We're leaving the reach of Saint-Hubert in Canada. We're going north. This one is in Norway at Svalbard.
Yes, we are close now to the North Pole, and this station, which is north of Norway, in the polar cycle, in fact, is close to the Spitsbergen.
It's unique because it covers all, I think, 14 daily passes of polar orbiting satellites. It's part of the Norwegian Space Center's operations, I believe, used also by NASA, and helping out with the Ariane program this evening. 680 kilometers up, the altitude figure and the speed coming up towards 8 kilometers per second, and the figure we need, you say, was 9?
About 7.6, something like that.
7.6, so we're getting there. We want to talk about something called passivation or blowdown, which happens to the
EPS
top stage after it finishes its burn. Huh?
Yes, a bit less than 2 minutes before EPS cutoff. Engine, the pressurization of the propellant tanks will drop until the engine cutoffs in order to avoid any risk of overpressure in the tanks or explosion due to overheating of the tanks later on.
Tanks can heat up
with the sunlight.
With the sunlight. It's not a question of the any extra drops of fuel being left on board. I thought passivation was once when they opened up the remaining stage and they drained it, so there would be no fuel left. It's not the same thing.
Yeah, because we have to keep this specific orbit free of any pollution.
Coming up on the extinction, and the DDOs just called it out. We have just had burnout of the upper stage, and you can see the flame being cut off right there. So we are flying on no power. We're flying on momentum.
Now we are in what we call the ballistic phase. In fact, the propulsion has stopped, and this phase will ensure the stabilization, in fact, of the composite in the direction required by satellites before their separation. And we will also try to synchronize the space between the different satellites we will separate. So this is the task of during this ballistic phase.
Ballistic phase, we call it. And it's going to last for how long?
So it's we should have the separation of the first satellite about 1 hour and 8 seconds from the liftoff. So
from liftoff time.
It's still more than half an hour now.
Now these are shots of what is going on right now?
So now we see the spin realized by the upper stage and separation of HELIOS.
This is not what's actually happening. This
it's just to show the sequence. And we see reorientation and spin down of the upper stage in order to point in the right attitude for the next satellites.
This is what you mentioned. You see Jean-Yves Le Gall is at the podium. We have just completed the powered phase of Ariane Flight 165, the upper stage, or the EPS. HELIOS 2A and the 6 microsatellites are in a stable orbit.
C'est-à-dire à peu près dans une demi-heure, alors que
They've just
l'ensemble
passed over
sera
northern
en
Canada and will soon be
visibilité de la
flying over the
station de
Arctic
Dongara
Ocean,
à
East
notre
Asia, and then the Indian Ocean. At 1 hour and 8 minutes after liftoff, in roughly half an hour, this composite will be visible by the tracking station at Dongar in Australia, and then HELIOS 2A will be separated and the 6 microsats afterward. So let's take a break, and when we come back, we'll witness these satellite separations and the completion of flight number 165. Thank you. So, Mr. Le Gall, giving everybody a rendezvous, as they say here, for in about half an hour's time. We're going to be back. We're going to give you, we're going to cut away here from the live portion, and while we're waiting for the satellite separation time, we're going to be showing you some interviews with people from the HELIOS program, from the ESSAIM, PARASOL, the NANOSAT, and some other subjects. I think there's one on Soyuz and some other things.
But I would like to add that during the out of visibility, after Svalbard station will lose visibility of the launcher, in fact, at that moment, the telemetry will be recorded on a specific equipment, which is on this vehicle, which is the memory extension box. It will be recorded, and this telemetry will be restituted as soon as we'll be again in visibility of Dongara in Australia.
That's right. Jean-Yves Le Gall mentioned that the satellite, the composite's now flying over the pole and down towards Canada and eventually towards Asia. There's no visibility there because we have no station there. So we'll have no telemetry. Which is why
again, after Dongara and before Kourou acquisition again, we'll use the same equipment to record the telemetry.
But we're going to keep the altitude and the speed. As you see, it's a stable orbit. We're going to keep that up for, I think, plus 34 minutes, another 4 minutes until we lose sight and signal. And it's like flying over the dark side of the moon. And we'll pick it up, as Jean-François mentioned, from the Dongara station in Australia in about half an hour. And as we said, during that time, you'll be treated to some interviews from the HELIOS, ESSAIM, PARASOL, NANOSAT people, and some other subjects. We hope you'll enjoy that break. All is normal and nominal on board. As we continue with the ballistic phase, another half an hour. So we'll give you a rendezvous at that time at we're at plus 31 minutes. So we'll see you back here when? At plus 57 minutes. And we'll have a recap of all that has gone on. We'll explain about the telemetry loss and the telemetry pickup. We'll have some news from Dongara. We'll talk about the ballistic phase as well. We might even have a quiz question if we have some time. And then you can talk more about the memory loss, and then we'll come up to a satellite separation of HELIOS, which is due at plus 1 hour and 8 seconds after liftoff. And that'll be followed very, very rapidly, so keep your eyes open. Don't blink or you'll miss it, because we have the 6 microsats coming up right after the Helios 2A separation, one right after another. You have the first one is NANOSAT, I think, which is the smallest. And then the ESSAIM group, the 4 of those, they'll be launched 2 by 2.
Yes, all these separations should occur about in 8 minutes. So it will be very quick.
8 minutes, we're launching 7 satellites.
Yeah, but we will comment as soon as we get the information.
So all that's ahead. We hope you will stay tuned. Don't go too far away. We'll be back at plus 57 minutes with the very end of the mission. We'll see you then.
Prevention and surveillance have become priorities in French military strategy due to current complex, uncertain risks and threats. They're based on specific capacities for detecting and evaluating indicators for crisis or conflict. Automated evaluation is backed up by a national chain for information collection, as well as by exchange among European partners. A wide range of sensors, space, aerial, maritime and terrestrial, is used to optimize information quality. Surveillance satellites play a major role among these sensors. They provide authorities with fast, reliable information, making France and its partners important actors in international affairs.
Le rôle particulier du satellite d'observation est de donner du renseignement en permanence. Il peut le faire puisqu'il tourne autour de la Terre 24 heures sur 24, et cela sans violer l'espace aérien des pays survolés. Il y a très peu de pays qui possèdent des satellites d'observation militaires. Et grâce au programme HELIOS, la France, l'Italie et l'Espagne, depuis 1995, sont rentrés dans ce club très fermé.
The launching of Helios 1A was the first step in building European space defense. This step was increased in December 1999 with the launching of a second satellite, Helios 1B, whose mission has just ended. The Helios 2 program marks the arrival of a new partner, Belgium, joining France and Spain in this second-generation observation system.
Les satellites, qui pèsent environ 5 tonnes, sont en orbite basse. Ils défilent le long des méridiens et par un mouvement latéral, ils peuvent accéder à tous les points du globe. Ils réalisent les images ligne après ligne pendant leur avancement et l'orbite a été choisie spécifiquement pour faciliter l'interprétation des images afin que l'éclairement solaire soit toujours le même.
La mission d'Helios, c'est de fournir des images aux forces armées. Et pour que ces images correspondent à nos besoins, il est nécessaire de programmer les satellites. Cette programmation, elle va être quotidienne et elle peut se diviser en 4 étapes. Premièrement, une étape nationale. Chaque pays va établir la liste de prises de vue qu'il souhaite obtenir et à chaque prise de vue, il va affecter une priorité. Deuxièmement, niveau international, tous les pays qui ont établi ces listes vont effectuer un dialogue international. Ce dialogue va permettre d'optimiser les listes initiales pour les rendre compatibles avec les ressources disponibles du satellite et permettra aussi éventuellement de constituer des demandes communes dites demandes internationales. Troisième étape, ce plan de travail il est transmis au satellite par le centre de maintien à poste qui se trouve au CNES à Toulouse. Quatrième et dernière étape, une fois que le satellite a effectué ses prises de vue, lorsqu'il passe au-dessus du pays qui a demandé ces prises de vue, il les transmet à ce pays. Elles sont reçues par un centre qui s'appelle le centre principal Helios. Ce centre, il décrypte les images, puis il les transmet aux utilisateurs pour qu'ils puissent les exploiter.
De nombreuses améliorations ont été apportées au système Helios 2, tant à bord des satellites que dans l'ensemble du système sol qu'il commande. À bord des satellites, des nouveaux instruments ont été implantés jusqu'à la très haute résolution, ce qui permet d'avoir des images beaucoup plus précises. Et l'agilité du satellite, qui lui permet de dépointer à droite ou à gauche, a également été améliorée afin de réaliser beaucoup plus d'images que dans la génération précédente. Le satellite a également été conçu pour pouvoir réaliser des images dans différentes bandes, le visible, le proche infrarouge et également l'infrarouge, ce qui permet d'obtenir des images de jour et de nuit sur tous les points du globe. Au sol, l'ensemble du système a été pensé afin de réduire au maximum le temps de réponse du système. On a mis en place des antennes au plus proche du centre principal Helios pour traiter très rapidement les images. Des modes de programmation urgents ont été implémentés dans le système pour programmer le satellite au plus tard. Et les cellules déportées au sein des forces permettent aux utilisateurs d'accéder directement à tout instant au système Helios.
Les améliorations du système Helios 2 ont nécessité d'importantes ressources et de solides compétences en technologie spatiale. Nous avons réalisé de nombreuses avancées technologiques et je pourrais citer deux exemples. Dans le domaine de l'instrumentation, nous avons développé des détecteurs très performants, spécifiquement pour cette mission. Nous avons mis au point un procédé original de compression des images, procédé qui a d'ailleurs été breveté. Le système Helios 2 est réparti sur plus de 20 sites dans 4 pays. Le déploiement d'un métasystème aussi complexe a nécessité d'importants moyens d'ingénierie tels que simulation, essais, moyens qui ont largement contribué à la maîtrise de bout en bout de cette mission de renseignement.
Tous ces systèmes s'inscrivent dans un cadre précis, qui est un document, il s'appelle le BOC, Besoins opérationnels communs. Ce document a été élaboré par 4 pays européens en 2001 et il définit ce que devra être le système d'observation par satellite de l'Europe. Après les coopérations Helios regroupant la France, l'Italie, l'Espagne et maintenant la Belgique, le développement des systèmes d'observation radar italiens Cosmos Skymed et allemand Sarlupe ouvre l'ère des échanges de capacités et élargit le périmètre des participations européennes à ces programmes.
At the beginning of the 21st century, the HELIOS system marks a new step in building a European space surveillance system.
Myriad microsatellites are light and modular, tipping the scales at less than 150 kilograms. They can be adapted quickly and cheaply to science missions in exploratory fields where results are not necessarily guaranteed. They can also be used to qualify and demonstrate technologies. Myriad rounds out Kinéissa's line of satellites, complementing the Proteus and Spot series. These 3 classes of satellite meet the full spectrum of space mission needs and can be tailored to fit available budgets. To reduce operating costs, Myriad shares certain ground facilities, procedures and control center resources with the Proteus line of mini-satellites. Demeter is the first microsatellite in the Myriad series. In orbit since the 29th of June 2004, its main mission is to probe electromagnetic disturbances in the upper atmosphere, related to geophysical phenomena such as earth tremors. PARASOL is the second microsatellite in the series, designed to study the microphysical properties of clouds and aerosols. 4 ESSAIM microsatellites will also be sent into orbit with PARASOL. ESSAIM is an electromagnetic intelligence demonstrator designed to extract information from electromagnetic waves emitted by radar and radio transmitters. Such information helps to detect emerging crises and prepare armed forces for deployment if necessary. ESSAIM is using Myriad microsatellites to drive down the cost of the demonstrator mission. Operational requirements may mean that the future operational system has to be built around a higher class spacecraft bus. The ESSAIM demonstrator will be operated jointly by DGA and the armed forces under the control of DGA's CELAR Weapon Electronics Center. Many other missions set to use Myriad microsatellites, such as Microscope, Picard and Spiral, are also being developed for launch in the years ahead.
We are with Eric Beaufumé, the satellite mission director for ESSAIM. Eric, you are from EADS Astrium, and my first question is there a definition for microsat?
Well, there's no single definition, but we can speak of a class of small satellites, about the size of a washing machine, say. Actually, it's better to call it a launch mass of about 120 kilos. They're small objects with lots of technology on board.
Essaim in French means swarm, like a group of bees. Are they flying in formation?
Alors à quoi sert cette technique particulière?
ESSAIM is a prototype which will explore certain techniques to carry out its mission, which is to study the electromagnetic environment. One of the interesting aspects of the mission is that the satellites will be flying in formation. This will allow us to gather data by different satellites in a coherent manner and to make use of them on the ground to highlight the mission's most interesting results.
Reconnaissance satellites usually look at pictures, but this one will listen to electromagnetic activity. Is this like listening to radio waves?
Exactly. It'll observe electromagnetic waves and radio waves in the different frequency bands. That's the ESSAIM mission.
I imagine that flying in formation like bees can be dangerous.
Donc il peut y avoir des risques.
Yes, setting up the system means a lot of complex operations. We have to shift the orbit, we have to position the satellites, and you're right, these operations are complicated and they are long. It'll take 3 to 4 months to put the whole system in operation.
Thank you, Eric.
Thank you.
Several million tons of aerosols, fine dust particles in suspension in the atmosphere, are emitted globally every day. These particles may be generated by natural sources, such as volcanic ash and desert dust, or man-made. We know that aerosols affect climate mechanisms, but uncertainties about the radiative impact of clouds and aerosols are currently one of the main factors limiting our understanding of climate and climate change. What role do aerosols play? And how will global warming affect cloud cover? These are some of the questions the PARASOL mission will attempt to answer. PARASOL is carrying a wide-field digital camera that will measure the angular signature and polarization of light reflected by the Earth atmosphere system. This camera has been modified from the Polder instrument to favor multi-directional viewing. It can acquire sequences of images in 9 spectral bands, 3 of them polarized in the visible and infrared portions of the spectrum. Its wide field of view and the ability to acquire sequences of images every 20 seconds mean the instrument can view ground targets from different angles. PARASOL is part of the French-US A-Train Observatory, a world-first formation of 6 satellites to be launched in the coming years. As well as PARASOL, France is also partnering the United States on another A-Train satellite called Calypso. Orbiting only a few minutes apart, these satellites will observe the same regions of the atmosphere, providing combined data to further our understanding of the radiative and microphysical properties of clouds and aerosols. CNES has also set up a new structure in Lille, northern France, to boost research in this area. Called ICAR, this structure is designed to support processing, exploitation and distribution of A-Train science data for the scientific community.
Our guest is CNES Vincent Dubourg, director of the PARASOL mission. What is PARASOL?
Well, it's sort of the opposite of the greenhouse effect. It's how clouds can keep the sun's rays from heating the planet.
This satellite is part of the Myriad family, developed by CNES for the scientific community. What is its main onboard instrument?
It's a camera, an imaging radiometer, a wide-angle camera which will take pictures of the different regions it flies over.
Parasol is designed for very precise orbit, but it will also be part of a fleet with other satellites.
Yes, Parasol will be part of Aquatrain, which is a formation of satellites whose job will be to study the environment and climate change at an altitude of 705 kilometers. Parasol will line up with a train of other satellites already flying. This formation will be completed in the coming years to eventually count a total of 6 satellites orbiting in line.
This mission will help understand how the planet's climate changes.
That's right. Parasol will greatly aid our understanding of climate changes and the effects that human activity can have on it.
Vincent Dubourg, many thanks.
Since 1993, the HELIOS program has used the know-how of the Alcatel teams for realization of high and very high resolution spatial instruments. We have set up industrial means which are unique in Europe. These included an optical vacuum chamber of 600 cubic meters, and we also have engineering capacity for controlling the entire image chain from sensor to image. HELIOS 2 instrument performances have been greatly improved compared with HELIOS 1. This includes a finer image quality with a very high resolution option and an infrared channel allowing for day and night activity detection. On the optical side, competencies we have developed on the HELIOS program have let us gain a major participation in the Pléiades high-resolution program for CNES with supply of high-resolution instruments. Manufacturing of microsatellites for a spatial alerts demonstrator, the Spiral program for the DGA. For radar, with manufacture of the Saralupe constellation radar for the German Defense Ministry, Alcatel has consolidated its role in the radar imaging sector. Alcatel is always ready to meet the challenges of major European projects and is a prime player in the defense space sector. Alcatel is also developing the Syracuse 3 telecom system. The first satellite will be launched early next year.
De bénéficier des dernières avancées technologiques dans le domaine des télécommunications.
Le lancement de ce soir est un événement exceptionnel pour EADS Astrium. EADS Astrium est maître d'œuvre d'ensemble du satellite Helios 2, de la plateforme, de l'instrument champ large et de la composante sol utilisateur. Je rappelle qu'avant Astrium, Matra Arianespace a été maître d'œuvre de l'ensemble des satellites de la famille Spot, Spot 1, 2, 3, 4, 5, Helios 1, aujourd'hui Helios 2, et demain Pléiade, programme dual qui apportera de nouvelles performances à la fois aux utilisateurs et militaires. C'est un investissement de plus de 20 ans dans une filière observation, une filière optique, qui aujourd'hui permet de donner aux forces armées françaises un instrument exceptionnel au meilleur niveau de la technologie mondiale et qui permet également d'élargir la coopération à nos partenaires européens. Sur le programme ESSAIM, nous sommes mandataires, en co-traitance avec notre partenaire Thales. C'est le premier démonstrateur militaire lancé en France dans le domaine spatial. C'est donc un événement tout à fait exceptionnel. Nous pensons que les nouvelles applications spatiales militaires, alerte avancée, liaison laser, navigation avec Galileo, mais également l'écoute communication avec ESSAIM, mais l'écoute électromagnétique, sont des applications qui vont se développer et qui vont apporter une contribution tout à fait significative à l'efficacité des forces armées et à l'objectif d'autonomie stratégique. Nous sommes donc fiers, en tant qu'industriels, de contribuer par nos compétences, par nos moyens technologiques, par notre expertise au développement de ces nouvelles applications spatiales militaires et d'apporter notre contribution d'industriels au succès et à l'excellence dans le domaine des programmes spatiaux militaires.
First work on the Soyuz launch facilities at the CSG, begun a few months ago, is nearing completion. The Soyuz pad is going up halfway between the Ariane launch pad and the town of Sinnemarie to the northwest. A meeting of ESA's board of directors last December 15th gave the go-ahead to step up pace of construction to prepare for the first Soyuz launch from Kourou in 2007. Arianespace has already signed with the Australian firm Singtel Optus for launch of its satellite Optus D2, which will be the first to fly aboard Soyuz from the CSG. Meanwhile, Soyuz 2-1A, the version of the vehicle equipped with a new digital flight control system, was qualified by a successful liftoff from the Plesetsk Cosmodrome on November 8th. This is the first stage of the program to adapt Soyuz to the norms of the CSG.
And back at the CSG, the microphone's working now. Welcome back. We hope you enjoyed the interlude. We have some news for you about what's been going on up there.
Yes, the news are good because we recovered telemetry from Australia. We should have an update of the figures now. And separation of Helios is not very far. It should be a bit more than 2 minutes.
2 minutes, right. So we've come over the blackout area, the North Pole, and we're now within range of our final tracking station at Dongora, which will see the separation of Helios and see the separation of all the microsats. So everything according to plan here in Kourou. We might, you want to go to the quiz question now?
Oh, if you like, yes.
Do we have time? All right. All right, they're getting ready to separate Helios in just about a minute. I think we'll go to the quiz question before the separation of Helios, the moment you've all been waiting for. Arianespace quiz question number 165. Get ready for this one. Now, you know tonight we're launching 6 microsatellites, which is unusual. But believe it or not, it's not the first time that Arianespace has launched 6 microsats, launched 7 in all. Question, when was the last time, the launch or the date, anything you have, the last time Ariane launched 6 auxiliary payloads? Once again, don't answer right away, you. Once again, Arianespace quiz question. Tonight we're launching 6 microsats. Unusual, but we've done it before. The question is, when? We'll give you the answer in about 10 minutes. Do you think you know the answer? Yeah, you do? Well, we'll see. We'll see at the moment of truth in 10 minutes. So anybody out there on the Ariane program, or maybe on one of the other programs, which we won't mention, the orientations for getting ready for the separation of Helios are coming to a conclusion. The time is 1 hour and 8 seconds. Three seconds towards separation now. What's the delay? What's the delay in time between the telemetry before it comes in here?
Or we should get very quick information.
We're waiting for confirmation of the separation of the satellite. Helios 2A. The news will be coming in from Dongar in Australia.
So separation of Helios has been performed. Everything seems to be very happy in Jupiter.
And you see the thumbs up in the crowd?
In any place else, in Paris mainly.
Very good. How about the in-flight operations now? Now that Helios is up, what
now
are we going to see?
have, in fact, a very quick operations. We'll have the software that will start the gyros to stabilize the satellite. The solar generator will deploy, and in fact, Earth acquisition mode will start also. In a few minutes, we should have secondary solar panel deployment.
Solar panel and solar generator, it's the same thing?
Yes, and in a 3/4 of an hour about invisibility of Kourou again, we'll have, in fact, the actuation of the solar arrays.
So it's taken 3/4 of an hour to make one revolution around the Earth, is that right?
A bit more, because in fact, we separated over Australia, and we should be in visibility of Kourou later on. And in 2 hours, the satellite will be fully deployed, and except for the instruments that will be started later on. In fact, the satellite will be ready.
Ready? All right. We are ready to go to one of our last films, a short film on the acquisition sequence for Helios. We'll be back.
The acquisition sequence begins once the satellite separates from the Ariane 5 launcher. The first operation is to partially deploy the solar array. Next, the spin rate is slowed and the satellite turns to face Earth. This fully automatic sequence, controlled by the satellite's onboard computer, is monitored by the control center each time the satellite comes into range of a receiving station. The thrusters, gyros, Earth sensor and attitude control system are now up and running. Once the satellite is in its exact Earth-pointing position, as it passes over the receiving station in Santiago, Chile, the solar array is fully deployed. The solar array drive, which constantly turns the panels to face the sun, then spins up to recharge the batteries and deliver electrical power to the satellite. One orbital revolution later, the high-resolution instrument sun shield opens. The acquisition phase ends with the release and spin-up of the momentum wheels that finally control the satellite's attitude. This is the last critical operation. The satellite is now ready to switch to pre-operational configuration.
All right, Jean-François, you just got off the phone from somebody. You have some
Yes,
news?
I just got the news that the orbit for Helios is really good, and they already started the deployment of the solar generator as I announced before.
We're coming up on NanoSat separation in just about 2 minutes. Before we do, when we have auxiliary satellites, we need an adapter. And tonight's adapter is something called the ASAP.
Yes, we have an adapter called ESSAP, yes. It's a ring, a structure on which we can install up to 8 microsatellites, and this is placed just above the vehicle equipment bay on the upper stage, below the main passenger, HELIOS 2A tonight.
NANOSAT, due to be separated in about a minute. NANOSAT is built and designed by Spain's National Aeronautical Technology Institute in Madrid. Spanish-built in-orbit demonstrator, they're calling it, of the operation of several telecommunication nanotechnologies.
It's the first nanosatellite for Spain, and it's weighing about 20 kilograms.
About the size of a microwave oven.
Or probably a bit more, because the dimensions are close to 50 centimeters.
Well, it's the size of my microwave oven.
Okay, you have a big one.
Also on board, some solar and magnetic sensors. Things are beginning to happen fast now. In just about 15 seconds, 20 seconds, we'll have the separation of NANOSAT. And then right after that, we'll have the ESSAIM satellites will be separated 2 by 2. The first number 1 and 4, and then 1 second, I believe. 1 second later.
1 second in between the two separations. So we can see a small black dot on the screen, which was NANOSAT.
That was NANOSAT being separated, right?
So it's separated now.
It has some experiments in communication aboard and with optical communications. Now, how about its in-flight operations?
In fact, in about 10 hours, we'll have acquisition. This is ESSAIM separation. We had 2 separations with 1 second in between, and you can see the 4 ESSAIM satellites, which are just in front of the EPS now.
ESSAIM is also a demonstrator designed to prove the feasibility of space-based detection of electromagnetic transmitters. As we mentioned, it's part of the defense program. It's an €80 million project developed by CNES with Astrium.
Yes, the particularity of these satellites, they will fly in formation, and it will probably be achieved, because it's a delicate operation, end of March 2005, and the system should be accepted and operational from April 2005.
You mentioned flying in formation. The 4 of them are close enough in formation to be simultaneously viewing the same regional zone and getting pictures from that, which is unlike the sort of constellations that we're used to, which are too far away to give us 4 snapshots of the same area.
Yes, but they are mainly for listening radio waves.
All these 4 satellites are going to be controlled from Toulouse in the control center. This was a turnkey operation, including the ground segments and the launch and all the operations for the ESSAIM people. PARASOL up next. They are just orienting the composite for its release. The PARASOL project is to study the impact of clouds on climate, and it will be flying at about 700 kilometers altitude. The project goes back to 1999 as part of Earth observation for the European space program. And there's the PARASOL. Separation
of PARASOL. We have all our minisats now deployed.
Well, you heard the people here in the space base very politely waiting until the final passenger had been released, separated, to applaud the mission as a whole. HELIOS and PARASOL, NANOSAT, and the ESSAIM group. So the good news here, 7 satellites now beginning life. Just one word on the A-train, as they call it, the PARASOL, but which is a Franco-American project with passive and active instruments aboard. The passive instruments, as they call them, will measure reflected sun rays, and there will be active LiDAR and radar aboard. The 6 satellites will pass over the equator roughly together around 1:30 in the afternoon. That's why they call it the afternoon constellation, or the A train. So the cigars and the champagne and the congratulatory parties will be forthcoming. We have 6 satellites separated in less than 10 minutes. That's pretty good. Did you get the answer to the quiz question, by the way?
Yeah, I think it might be Spot 2 and some 4 mini-sats and 2
It might be Spot 2. The question was, we're launching 6 microsats.
On V35.
On V35. Actually, you're wrong.
Yeah.
I'm sorry. You're not close. You're not far. You had how many micros on that?
6.
You had 6. You had 6. You had 6 satellites. Oh. The answer actually is Flight 59. Ariane in 1993, Spot 3. Do you remember the passengers? Stella.
Yes.
An American one called ISAT, an Italian called ESSAIM. These weighed 10 kilos. There was a Portuguese and a South Korean, POSAT, KITSAT, and another American satellite. You said Flight 35, where there were only 4. But you got close. Well done. Anybody get the answer out there? It was flight number 59 in 1993. Give us a call up here at 35862 and you'll have Jean-François's personal check for 165 euros. We're waiting for Jean-Yves Le Gall.
Vous l'avez vu, à l'issue d'une mission parfaite, on est parti à l'heure et on est arrivé à bon port. Ariane 5 vient de placer HELIOS 2A et les microsatellites ESSAIM, PARASOL et NANOSAT sur leur orbite. Je voudrais donc d'abord remercier le ministère de la Défense qui, une fois encore, a fait confiance à Arianespace. Je voudrais aussi remercier les équipes techniques du CNES, de l'industrie et d'Arianespace pour ce lancement parfaitement réussi. Je voudrais enfin remercier les États membres de l'Agence spatiale européenne, au premier rang desquels naturellement la France, qui voit ce soir la concrétisation du secteur qu'ils apportent au secteur, du soutien qu'ils apportent au secteur des lanceurs. Alors une fois encore, bravo à tous pour ce superbe succès. Et sans plus tarder, je passe la parole à Madame le ministre de la Défense qui va nous faire l'honneur d'intervenir depuis l'école militaire à Paris. Merci.
Jean-Yves Le Gall, thanking everybody, talking about a successful mission. We're going to go now to a phone link with the French Defense Minister from Paris.
Bien, en premier, un grand bravo à tous. Je crois que nous sommes tous heureux et fiers d'avoir été le témoin de ce grand succès qu'est le tir du satellite HELIOS 2A. Je voudrais remercier à mon tour, en premier, les hommes et les femmes qui ont travaillé sans relâche pour rendre possible cette réussite d'aujourd'hui. C'est un nouveau succès pour Ariane 5 et je salue la mobilisation continue de la filière des lanceurs. Ce moment, événement majeur pour la communauté spatiale, est non moins important pour la défense de notre pays et de l'Europe. Avec HELIOS 2, nos forces armées pourront bénéficier de capacités supplémentaires, d'images plus précises, de plus de réactivité. HELIOS 2, c'est aussi un nouvel exemple de la qualité de la coopération européenne en matière de défense. C'est la réussite de la coopération entre gouvernements comme entre industriels. Fort de ce succès, nous devons poursuivre cette voie. La maîtrise de l'espace est bien le prochain défi que les Européens auront à relever ensemble. L'espace est un enjeu majeur du XXIe siècle. La France et l'Europe ne peuvent rester à l'écart de ce défi. Notre pays, qui conduit actuellement une politique ambitieuse de modernisation de ses applications spatiales, doit continuer à entraîner ses partenaires européens sur cette voie. Oui, l'espace est un enjeu stratégique majeur pour l'Europe. C'est un enjeu économique considérable. C'est une pièce centrale des outils militaires modernes. Et je pense que la France et l'ensemble de l'Europe doit en prendre davantage conscience. Maîtriser l'espace, c'est un impératif pour demain. L'importance des technologies de l'espace aujourd'hui est comparable à celle des sciences du nucléaire dans les années 60. Le statut de puissance spatiale est devenu indispensable pour exister sur la scène internationale. De nombreux pays conduisent déjà une révolution spatiale avec détermination et avec des moyens très importants. De plus en plus, j'en suis persuadée, la maîtrise de l'espace est au cœur des dispositifs militaires modernes. Cela s'est d'ailleurs encore vérifié lors des conflits aussi bien au Kosovo qu'en Irak. L'espace, c'est un moyen de renforcer les capacités militaires en améliorant leur efficacité. C'est particulièrement vrai dans les opérations qui s'effectuent loin du territoire national. C'est une condition de notre autonomie d'appréciation des situations. Il est donc essentiel que la France et l'Europe approfondissent leurs réflexions sur l'utilisation militaire de l'espace. Face aux menaces actuelles, diffuses et multiples, nos forces de défense doivent disposer de ces moyens renforcés, innovants, de renseignement stratégique et de télécommunications. Nous devons également investir davantage d'autres champs d'application du spatial, comme l'écoute, l'alerte avancée, la surveillance de l'espace. Galileo, qui sera accessible aux armées, est une première réponse dans le domaine de la navigation. Mais nous devons encore progresser. La France s'efforce de faire partager sa vision, sa conviction à ses partenaires européens pour les entraîner à développer avec elle une politique spatiale plus ambitieuse. C'est ce qui nous a conduits à présider, dans le cadre du plan d'action européen pour les capacités, le processus ECAP, le groupe de travail sur l'espace. Compte tenu de l'importance de ces enjeux, j'ai aussi décidé de créer un groupe d'orientation stratégique de politique spatiale de défense. Ce groupe, présidé par François Bujon de l'Étang, m'a récemment remis ses conclusions. Elles confirment la nécessité et l'urgence pour la France et pour l'Europe de conduire une politique spatiale ambitieuse. Le travail du groupe d'orientation fournit une matière riche que j'entends exploiter dans les prochains mois. J'entends en effet que la France ait les moyens de moderniser et de développer ses applications spatiales et d'entraîner ses partenaires européens sur cette voie. Le lancement auquel nous venons d'assister témoigne que les efforts fournis grâce à la loi de programmation militaire 2003-2008 commencent à porter leurs fruits. Toutefois, ce n'est pas encore suffisant pour être à la hauteur de l'enjeu et de nos ambitions pour l'Europe. La loi de programmation militaire est une première étape. Elle maintient la France dans le club des nations qui comptent dans le domaine spatial. Elle a permis le lancement d'HELIOS 2, qui est le premier grand rendez-vous spatial de la période couverte par la loi de programmation militaire. Elle permettra également, en mars 2005, le tir de Syracuse 3, un rendez-vous qui, je l'espère, connaîtra le même succès. Grâce à la loi de programmation militaire, nous pourrons également préparer l'acquisition de nouvelles capacités. J'ai ainsi lancé une politique de démonstrateurs indispensable au développement des futures capacités spatiales. Le satellite ESSAIM, qui vient d'être lancé aujourd'hui avec HELIOS, en est la concrétisation dans le domaine de l'écoute électromagnétique. Fort de la matière fournie par le groupe d'orientation stratégique, nous devons créer un nouvel élan. Nos efforts doivent s'inscrire dans une coopération avec nos partenaires européens, car seule une dynamique européenne permettra de répondre à l'ampleur des besoins. Dès maintenant, nous devons définir les programmes que nous mènerons en commun dans un proche avenir. Cette nouvelle dynamique nécessite également de préparer les technologies dont nous aurons besoin. Notre effort de recherche nous permettra de donner une impulsion à cette démarche qui doit être résolument européenne. La France aura à continuer à jouer un rôle moteur dans ce domaine en initiant les démonstrateurs qui préparent les futurs programmes et en favorisant les coopérations autour d'eux. C'est dans ce cadre que j'ai décidé de lancer les travaux de préparation des systèmes spatiaux qui devront prendre la suite du satellite HELIOS 2. J'invite mes partenaires à nous rejoindre dès les premières études qui seront menées en 2005 afin de bâtir ensemble les programmes dont l'Europe a besoin. Je compte faire d'autres propositions encore dans quelques mois pour que la France puisse poursuivre et approfondir sa politique spatiale de défense et contribuer à celle de l'Europe. Je terminerai en renouvelant mes félicitations aux équipes pour le succès de ce soir. Le succès du lancement d'HELIOS 2, c'est un grand pas en avant pour notre politique spatiale, qui est une source d'optimisme et qui nous engage à regarder résolument vers l'avenir. Ce succès, c'est aussi le succès commun de plusieurs nations. Il prouve, si cela était encore nécessaire, la détermination grandissante des Européens à relever ensemble les défis stratégiques de demain. Je vous remercie.
Madame Aliot-Marie, calling this an important moment for European defense. Jean-Yves Le Gall will take the microphone once again, and then we'll go to a replay or two. You can see the shots of liftoff again. Jean-Yves Le Gall making his way to the microphone now for the final words.
Donc, pour les gens qui sont ici à Kourou, il me reste à vous remercier pour votre attention et à vous donner rendez-vous au début de 2005 pour le prochain lancement. Il s'agit, vous le savez, d'Ariane 5 ECA. D'ici là, je vous souhaite un joyeux Noël et une excellente année. Merci.
We're going to go to your first replay now.
Les paramètres bord sont normaux.
Well, 3 different shots from 3 different sites, as you can relive those moments that happened over an hour ago of the successful launch of the flight of Helios 2A, joining the family. Now, Europe has a new eye in the sky. Helios 2B will be coming along to join the family. They're talking about, what dates have you got?
2006, I think satellite should be ready, and launch is normally programmed in 2008.
2008. So that'll complete, I suppose, the Helios family. The minister, Madame Marie, talking about some future projects, which she has decided on. But the nanosatellites and the ESSAIMs and all successfully launched tonight. The big news here from Kourou. And Arianespace has now launched 271 passengers in all, orbited 252, 212 main passengers, and 46 auxiliaries. A big jump tonight with the 6. A total accumulated tonnage, can you guess what that is? 550 tons. Well, that'll do it from Kourou. A letter-perfect countdown, picture-perfect launch. Any final words?
Yes, I would like to wish everyone very good holidays for Christmas, and I must say we are very, very happy of this launch today.